Hello, good day. We are Vogue Design Solutions. My name is Gideon Patrick. I worked on some of the storybook designs and the delegation of tasks.
My name is Julian Charles, and I worked on concept design and literature review.
Hi, my name is Mario Pacheco. I worked on one of the pattern reviews and also helped in the lit review where they talked about the functionality of this individual.
And my name is Vasily Maharaj, and I worked on the introduction as well as a pattern review on some of the designs and trends.
It is proven that citrus juices are in fact low-calorie, healthy sources of energy and rejuvenation. This integral aspect of multiple weight loss diets has proven to be an essential part of our lives, and even more so, the lives of those who are health conscious. All the more reason for this juicer to be added in the customer's health club. Grapefruits and oranges offer energy as well as vitamin C, and even helps the body to form amino acids. These same amino acids have been proven to improve the cognitive performance, digestion, and even muscle tone. The motivation for this project was to come up with efficient concepts for the citrus juicer. We had many ideas as a group and even sought to recall information that we learned in previous courses, such as statics and strength of material, machine design 1, and even machine drawing. Due to this prior knowledge, we were inspired to come up with this design. When living a health-conscious life, the caloric intake and the benefits of said calories are crucial. This product allows the user to have a pre-workout, mid-workout, or even post-workout source of energy and nutrition. The juicer allows for the ease of making elaborate health smoothies. Problem statement. For this project, our group has been hired by an exclusive health club and gym that produces elaborate smoothies for their clients to design a unique citrus juicer that would enhance the experience. The objectives of this project was to conduct relevant patent and literature reviews that aid in the design of the juicer, determine user and client requirements and key attributes to guide design concept generation, to create 3 juicer concepts and to select the best suited one, to also model and simulate the final design, and to even create a prototype to demonstrate how the juicer will work.
Literature review. Basic operation of a typical citrus juicer. A juicer is a tool that is used to extract juice from various fruits, vegetables, leafy greens, or herbs. It takes the juice out of the pulp by grinding, crushing, or squeezing. They can be manual or mechanical, and of course, the mechanism affects the productiveness of the device. The simplest juicers consist of juicer reamers made of wood or metal that have cone-shaped heads with gear-like protrusions, built to be pressed against the meat of the fruit half in order to extract the juice. There are several different shapes to the head that are produced, ranging from stout and round to narrow and more pointed. Each serves to accomplish the task of breaking apart the flesh and providing juice. Other varieties of handheld utensils include juicing squeezers or pressers, juicing funnels, or bowl juicers. The juicer squeezers, which function as a juice press, use a procedure to either press against the flesh of half the fruit to extract the juice, or press against the rind to turn the rind and flesh inside out for extracting. In fashioning a mechanical device which interacts directly with fruit juice, which is essentially a chemical, 2 main factors were considered: the interactions of the fruit juice constituents with heat. It was found in our research that citrus fruit juices contain 2 main nutrients, vitamin C and potassium. Vitamin C began to degrade at 86 degrees Fahrenheit, according to research conducted. As such, it is necessary to engineer a device that places motors and other heat-generating items away from the storage area for the juice and prevents the juice from spending a long time in the machine. Research shows that acids in general show reactivity with metals. However, vitamin C, otherwise known as ascorbic acid, is a weak acid and does not show strong reactivity with metals. As such, no special considerations need to be taken.
Patent Review 1. This juicer has a base 10 that encloses a pair of electric motors that drive 2 spindles, 13 and 14. The 2 spindles are connected to 2 juicing cones, 19 and 20. which spin at a set speed to juice the two halves of a citrus fruit. The juicer also has a lid 25 that is arranged to extend over the juicing cones and when closed applies pressure to the halved citrus fruit while the juicing cones are spinning. The juice is then drained through the opening 21 and collected in the container 22. The lid and the container can both easily be removed for cleaning and reattached for repeated use.
For this patent, half a citrus fruit is placed into a perforated cone 9. This, of course, is even a form of straining, keeping the seeds out of the juice and crushing the pulp. The grooved cylindrical shaft above the cone 11 works with the handle 15. This handle is turned and the gears of the shaft 14 connect with the grooves, compressing the fruit against the cone, leading to the fruit being juiced and said juice going to the spout 7 and then to the final cup at 5.
Review number 3. The fruit goes down 79 into a cutting mechanism which severs it. The severed portions being held against dislodgement is carried along via fruit cups directly into the reamer, which is connected to a motor that is simply supported. The reamers then extract the juice from these portions, and then there is a strainer which separates the juice from the seeds and pulps under the waste. Juices which are free of seeds and pulp gravitate to and through the spout 51, whereas the seeds and pulp which are conveyed through the strainer by the screw are delivered through a passage to a chute 52, through which the fruit skins find their exit from the interior of the machine, as will presently appear.
The fruit is slid down the chute 1 and forced against the cutting blade 2. The two equal halves are directed by the cam pedestal 3 onto the male squeezing part 5. The female squeezing part, not shown, compresses the fruit. The seeds and pulp remain trapped by the membrane 4 and the juice is collected in the area below.
Client and user requirements. The machine should conform to the following design specs: safe operation and shielding from moving parts. It should be easy to maintain, have minimal vibrations, and also be suitable for small-scale operation. Design constraints. The machine should conform to the following design constraints. It should weigh less than 5 kilograms, run at less than 500 RPM, draw less than 800 watts, and also fit within 500 by 200 by 200 centimeters. Key attributes. These are the attributes that the group thought were most important to our project. The first, low cost, user-friendly, effectiveness, durability, time span, and most of all, quality. This metrics table put the key attributes against the rankings 1, 2, and 3, where 3 was the best and 1 was the worst. This information was used in attaining the relative weighting from the pairwise comparison chart. In this comparison chart, the key attributes were put against one another to determine which attribute can be deemed as the most relatively weighted in our design. For example, cost was put against user-friendliness. Here, the user-friendliness of our device was preferred. Thus, user-friendly gained a 1 and cost got a 0. This concept was applied throughout, giving a total, then finally, a relative weighting. Black box. This diagram has the inputs required for the process, being fruit, instructions, and energy. Once these inputs go into the citrus juicer, the desired outputs would be juice. However, there would be other outputs such as waste and sound. Transparent box. In this diagram, the input to the process, fruit, has a force applied to it to acquire the juice from the fruit. It is then filtered where the rind and seeds are left back. It goes to the cup where it is collected, then shaken with its additives to give the final product.
Functional mainstream. Juice making, which could either be automated or mechanical. This is what is needed by the client, so this becomes our main function. Extracting juice, filtering, and collecting are things we do to achieve the juice, which are called sub-functions. The strainer, container, human force cutting, spinning reamer are things we do to achieve the sub-functions, which are called means. The morphological chart. This shows the different options to achieve a specific action. For example, turning on the device. You can either turn it on by using a button, by voice command, by using a sensor or a switch. And out of these 4 options, the person will choose which one is the most suitable.
Concept Design 1. This design brings together some general concepts from the leading juicers on the market. The operation of this device is intuitive and very user-friendly. The half-cut fruit is pressed onto the reamer, pressing down a spring which then engages the motor, causing it to rotate and extract juice from the fruit. The juice then passes through the strainer and into the agitator cup via the tongue. During this process, the cup should be uncovered. In the agitator cup, sugar, water, and essence can be mixed at the press of a button for a first juice smoothie. Here are some additional views of Concept Design 1.
The press 7 is removed and the citrus fruit is positioned against the male cutting part 12. The press is inserted and the citrus fruit is driven over the male cutting part where 2 equal halves roll along the body chassis to the back wall. The 2 halves face the center wall which divides the chassis into 2 equal parts. The handle and squeezer, which is coupled to the handle, are pulled down and the juice is expressed from the citrus fruit. The juice drains into a slot located near the base of the separating wall and flows out to a spout located to the back of the juicer. Here are some additional views of Concept Design 2.
Concept Design 3. This fully automatic juicer concept endeavors to maximize ease and efficiency. The oranges enter the top basin and travel to the rollers via the chute and gravity. The rollers will squeeze and force the fruit over the cutting tool. The half-cut fruit will then be picked up by the crusher that is rotating in the other direction, forcing it to be squeezed against the rollers, extracting the juice from the fruit. The juice will be collected in the catchment at the bottom and will be readily available by opening the tap. The remains are discarded out the exit chute. Here are some additional views of Concept Design 3.
Design Selection Matrix. In this matrix, the key attributes and relative weighting are shown. These key attributes are applied to the 3 concept designs. The concepts are given raw scores with these attributes in mind, from 1 to 3, where 3 is the best score. These raw scores are then multiplied by the relative weighting, giving a weighted score. The weighted scores for each concept are then totaled. In this matrix, we can see concept 1 having a larger score by a wide margin at 2.52, followed by the 2.11 score of concept 3, and lastly, the 2.03 score of concept 2.
We chose Concept 1 as our final concept since it had the highest rating from the design selection matrix. The only addition to our final concept was a planetary reduction gear system because our selected NEMA 17 motor runs at a higher speed than our desired range. This concept was deemed the best because of its ability to provide the user with high quality juice and enhance the user's experience in the gym. Here is a view of all the components of the juicer. The now shown figure is a sectional view of the spring mechanism that engages the motor. This is the planetary gear system that is within our juicer. And here is a short animation of how it works. Thank you, and I hope you enjoyed the presentation.